So Ashmin has 24 plus years of experience with the energy grid management business as an engineer and a leader. He has had the opportunity to lead many innovative and technically challenging projects in both the energy management system and energy market management system around the globe, and has been awarded multiple US patents for his innovation in the grid management and energy scheduling areas. He is currently serving as the head and senior key expert of the energy management market team of Siemens Digital Grid. And he has a master's degree in both power systems and computer science. And so with that, I am going to go ahead and turn things over to Ashmin.
Thanks, Melissa, for giving me the opportunity to speak to our future generation, I will say here, that they will shape the world. And today I will talk about three important things to the kids. First thing is I will talk about what is the mega trend that's going around the globe, and what are the coming challenges, and what we need to do in order to make those challenges. So these are the 5 mega trends that is happening around the globe. First thing is the demographic change, is that more and more people, 20% of the global population will be age 60 by 2050. So which is 30 years from now. And a lot more people are moving to urban areas. And this is happening around the globe. People are leaving the rural areas and they're coming to the urban areas. And very soon I will talk about what are the impact of these things. Digitization that's happening at an extremely rapid pace. 20 years ago, we have seen the cars, and now we see the cars that are loaded with electronics. And the similar thing happening on the energy sector or the power sector, that digital meters are coming, digital control is there, IoT devices are coming. So massive, fast amount of digitization is coming into the market. And global trading is also increasing at a rapid pace. No matter what we say, things are happening around the globe, that things are shipping from one place to the another. People are creating certain things in a certain place. So the globe is opening up, and we are no more kind of like, concentrated into something. And the climate change is definitely happening. You have seen the massive amount of flooding happening. We saw flooding happened in places that we have never seen before, like Germany, in Europe, and other places. And what is happening is that to respond to the climate change, the new forms of energy devices are coming in, which is solar, wind, storage like battery, and other things. I'll say that tidal wave, many other things are coming. So this is the global trend, 5 major trend that is happening. So what does that mean? That means is that the power that we consume every day and our home, and we turn on the electricity, we expect the power to be there, is coming from 10, 15, 20 years ago, used to come from coal, nuclear, oil. Slowly it moved to gas, kind of displacing the oil and coal to some extent. Now it's coming from the renewables. What are the renewables? Say wind and solar. They're the most form of the renewables that are available. So 2000, it's like 20% of the total consumption in the global average. We are somewhere around 30. By 2050 will be 50%. And many countries around the globe, we recently had that conference in Scotland, COPA, and many countries around the globe are pledging to be carbon neutral in 30, 40 years. And many states here in the United States are also pledging to be carbon neutral, that we all want to be responsible for the environment. So let me go back in time and talk about how this all started. How did the electric grid started? And it started in here in the United States, in the Paul Street in New York. There was a DC electric plant by one of the greatest minds of humanity, which is Thomas Alva Edison. He created this and supplied to different street lamps. And very soon they realized is that the DC cannot go too far. And not all the loads, all the houses can be near the plant, and not everybody can build one in their own house. So the power need to go where the people are. And hence, because the DC causes so much loss, cannot go, the another genius, Nikola Tesla, he come up with the alternating current power. And now AC current, by increasing the voltage, we can send it to far distance. And that is how it all happened. Somewhere the power plant was produced, and somewhere the power plants connected together. We can bring transmission line that you see all over the place in Minnesota here. They carry a lot of power, and they bring the power to the people. And then we thought is that, okay, we have all this power, and how to expand this? Because imagine all the power plants are producing power at certain money, they have to spend some money to produce the power. What if we bring like 10 and 50 or hundreds of those, and that will lead to reduction of the power. So how we started building power where the coal mines are nearby, where the oil is nearby, and all over the place, and connected all of them so that the power can be cheaper, can be delivered efficiently. And that is how this is called as the world's biggest machine. All of you are interested in machine design. If the question comes, what's the world's largest machine? The electricity power grid is the largest machine in the world. It's a live thing. It's a live machine that moves the power between the power plant and to our homes, to factories, and wherever we need. So, and in this picture, you can see that how this whole landscape is changing. And when you go around your neighborhood, you will see that the people are started putting solar panel. And then the question comes, is all the powers are still coming from the power plant, or they are locally available on our rooftop, or coming from that wind turbine that is rotating nearby? And that is the change that we are going to talk about today, is that how this thing is changing. So we have the transmission grid, all those high voltage power lines that you see that goes near the interstate, huge ones, they carry a lot of power, up to, and then it comes to small substations, reduce it, and that comes to our, homes and the factories. So what's the US transformation? This is changing right now. We are at a time when, Nikola Tesla's and Edison's time, but we are at another time then when this is changing. And this is changing because from a centralized grid, we are going into a distributed grid. What is a centralized grid? That means the power is generated somewhere, and the power comes one way from the plant to our home, or from the plant to our home, unidirectional. Not anymore. It's bidirectional. Why? Because we are producing power. I have solar panel on the top of my house, and I am using it. If I'm going on vacation, what do I do that power? That power need to go. So what the power is to come to us is now coming as well as going. So that is what is called as a prosumer and a consumer. So from a consumer, that we are just consuming the power, we are consuming and producing. And that is the big change that's going to happen. So what is the future? And What is how the grid will look like, buildings and the industries will look like. So this is what I was telling. From the unidirectional centralized power source, we'll move to a decentralized power generation. And that is where you can see that we have the cars that will be charging a Tesla. There you go. And you have the solar panel on the top. You will have a storage in terms of Tesla or a battery. Now imagine having a battery in your home that when you are going on a vacation, you can charge your battery, and when you come up, you can use that power. You don't have to take the power from the utility. And if you have more than what you can store, you can sell it to the utility and make money. And then if your battery, for example, goes bad or need maintenance, you can always purchase power just like what we are doing today from the utility. And that is happening across millions and millions of homes. In 20 years, USA grid will completely change into this kind of model. And so instead of gas stations, we'll see a lot of charging stations, EV cars will come and will change. So another big thing is happening, and I want all of you to think about it, that our houses, they're passive. The power comes and we turn on the heater, we turn on the air conditioner and everything. And the large malls like Mall of America and the big towers we have in the Twin Cities downtown, they're consuming power. And that is another place where the change is happening, that from very passive mode, they're becoming very active. What does that mean? Is that they have brains of their own. They can manage themselves. They can interact with themselves. They can store power when they need. Suppose there is no person on a room, they can reduce the consumption of the power. Depending on, we don't have to set the setting to a certain degree, depending on the number of people in the room, depending on the heat that is generated, it will automatically do that. And that requires a lot of computation and a lot of artificial intelligence. The artificial intelligence is doing what? It is creating a human brain, decision-making capability. It can predict how many people will be in this room depending on for the meeting. And depending on that, it can control the room temperature. It can control the light in the room. And thus, the power that we always thought it is there, I can turn it on, I can turn it off. The power is now managed to a very greater level. And that is what the society we are responsible for. When we reduce, we are not reducing our comfort, but when we optimize the power that we are consuming, we are creating less stress on the ecosystem that is producing power, that is producing carbon. So demand side will manage it, supply side will manage it. And so similarly, what happens in the future is this is where the smartness is coming into, and we are producing the smart power. We have now the smart grid, and we have the smart building. So this is how we tie all these things together, and we'll create this new world that is carbon free. And all of us will be, working on this. So I'll talk a little bit about me, and Melissa already talked about it. And so what I do is that I am head and a senior key expert of energy market management. And so we work globally. I have a global role, and I lead the Global Center of Excellence from here in Minneapolis for Siemens. And across the globe, we work to do this thing, is that what's the best way to produce power? What is the best way to take the power from the generation to the people? What is the least cost the power can be produced? What is the reliability the power can be delivered? That today you have power, tomorrow say I don't have power. That is not 24/7 you have the power. So a lot of work goes behind it. And those are my key responsibility. My key responsibility is to innovate new things and make it happen. And so what are my growth and the advancement potential? If I talk about, after finishing my grad school, I joined this company as an intern, and now I'm a senior director. So the growth is amazing growth you can happen. This is a growing field. This is a need of the people. And I encourage all of you, all of you be engineers, let's, work to solve the problems. And the growth is you can be entrepreneur. You don't have to do the job. Recently I was involved with building a startup. So you can all be entrepreneurs. You can build, you can all be Thomas Edison and be the next Thomas Edison and build something. So there is plenty of potential in this area, and it will continue to grow. Then typical day is, I'm a problem solver. So my office hours are from 8 to 5, but many a times I'm working a little bit late or a little bit early. I have a global role, and sometimes I have meeting with people in Australia, sometimes in Germany, sometimes in India, sometimes in Brazil. So time can vary depending on that, but we have flexible work policies. So if I'm working late, I can start next day late and things like that. But one thing I wanted to say, if you have expertise, you have demand, and people want to know, what you can do. How did I choose my career field is something that I love problem solving, and somehow I was fascinated by electrical engineering. And so I did a master's in electrical engineering, but I soon realized is that electrical engineering is good, but I need to build tools using the electrical engineering knowledge that the people can use. And that is when I went to school and did my master's in computer science. I'm an alumnus of University of Minnesota. So here I went to grad school here, and yeah, so that I have kind of best of both the skill set. And what is the best thing that I enjoy? I enjoy solving problem. If there is a problem to be solved, I can't sleep. And that's the best thing I do. And the other part is what I do makes a difference in people's life. So one of the work that I have done, the patent I have done is that innovation that I have done is, what is the best way to use the wind energy and use the storage to store it and use it so that we don't have to turn on the gas-fired generations. And it is saving already a lot of carbon that goes into the world. So when I see my work is really happening, I feel very good about it. And so here is my contact. If you need to know anything about it, please contact Melissa. I can, give you some answer if you have any questions. And I just want to, this is great opportunity. I just want to thank you from me and from Siemens also for giving this opportunity and have the opportunity to talk with you. Thank you. Thank you, Melissa.